Okay, so now let's see how we could have a VLAN spread or across many switches, two switches, and how to communicate from a machine in one switch to the same VLAN, but the destination is connected to the other switch. So what I'm going to do is I'm going to put two switches. So this is one switch, and let's connect it to 4 PCs. This is one PC, second one, third and fourth one, and I'm going to put another switch and connect this to 4 PCs. Okay, and I'm going to put them, give them the label first, which is going to be in the 10.0 prefix. This is also going to be in the 10.0 prefix, and this is going to be in the 10.0 prefix. Okay, and these 4 are going to be in the 20.0 prefix. Right, so I'm going to connect them using cables. Need a straight through cable to connect a computer to the switch. Let me use 0/2. /3. This guy to this 0/4. This to this 0/5, and let me connect them first. So this to this is going to be 0/2, so it'll follow the same order. And I'm going to set the IP addresses. Let's do it quickly. Okay, so set the IP address for those 4 machines. So let me set for these. Alright, so you also have to make these two. These are all of them are in VLAN 1, so we need to create a second VLAN. So let's go to the VLAN database, create our VLAN 2. Let me give it, instead of VLAN 2, a different number. You could ask me why I always give 2. Let me give 2000. Doesn't matter. Okay. Not sure that's a valid name. Probably it's expecting okay. I'll find out what's the valid range of VLAN numbers we could give. Okay. Alright, we could give 20. So 0, 2 and 3 are in VLAN, are going to be in VLAN 1, these two interfaces, but 4 and 5 are going to be in 20. Alright, you see that turning red or orange. Okay, so now let's put this already in VLAN 1, but let's put these two in VLAN 20. And 5. Okay, now we need to connect these two switches using the crossover cable, because there are two switches. So we'll use 0/1, that interface, and by default it is going to be in VLAN 1, right? If you click on that and see, this is going to be in VLAN 1. So if you want to communicate between a machine here in VLAN 20 to a machine here in VLAN 20, we cannot do that using this crossover cable. So as a brute force approach, I could connect another crossover cable in, say, interface was 6. This is interface 46, and put that both sides into VLAN 20, right? I could do that. Alright, so one cable, crossover cable for every VLAN. So I could try to now run a ping command with someone over here, so 192.168.20.10. We'll see what happens. They're still trying to reach out, so we may have to wait for a while. Let me try the other one in the time being. They're still orange. Okay, now I think we could try this. Okay, so we got the reply. Alright, so let's try on this side. On 192.168, say 10.11. We'll get back the reply. But you see, it is too much of an overhead to connect multiple cables, right? So far we used, every time when we try to put something, we use the access mode. The access mode, I said, is to connect a computer to a switch, or in this case we connected these two switches also using access mode. Instead, we could connect these two switches using what's called a trunk mode, right? So by default, trunk puts everything, all the available VLANs that are the VLAN numbers that are over there, into one single trunk. It's like a tunnel. So we could remove the things that we don't need and then you get something like this. Say for example I remove 1002, so we have 1 to 1001 comma 3 to 5, right? So we could remove them too, so it gets updated automatically. Alright, so everything before 1002 is now part of this trunk. So what happens when you put it in a trunk is actually forgot which one I configured. Let me remove both of them, because we really need only one cable. So let's just use one crossover cable to connect this 0/1 0/1. Let's put it in the trunk as I just now did. Okay, this is in the trunk right already, so I think I did for this guy 0/1, right? So let they communicate and set up the connection. So basically everything coming to this switch will be put on this trunk and it goes to this switch. So this switch should also be configured. Let me configure this side. It is also on trunk 1 2001. This side is also on trunk 1 2001, right? Okay, let me remove this. This is by default, right? So on 2001 on both sides. So now this switch will then be able to separate it out and look in which VLAN ID. So if you look at the packet, there will be a kind of a tagging going on in the packet. So in the Ethernet header, you'll have the VLAN ID attached to as part of the header. So if VLAN 2 is trying to communicate across this trunk, once it gets to the switch, or once the packet comes to this switch, it knows that this message comes from VLAN 2 and wants to go to VLAN 2, right? So it will attach a header, a tag that says this is a trunk packet and it has to go to VLAN 2, and it will send out on this trunk. And when it gets to this one, this is also a trunk packet, and it look where is the what's the destination VLAN ID, and based on that it will route to that interface. Okay, so that's how trunking works. So basically like a tunnel, you attach as part of the Ethernet header the VLAN ID that is used, that is the underlying VLAN for this communication at the originating point of the trunk, and then at the end point of the trunk, this switch, it will look at the VLAN ID and forward it further to that VLAN. Okay, so let's try to run this. So now we could try to communicate with the same 20.10. We'll be able to communicate. Now that's going through part of this trunk. Alright.